right, let's get started. Good morning, afternoon, evening, everyone, from wherever you are located. Welcome to iTrust's Maritime webinar on autonomous ship, current and future cybersecurity challenges. My name is Mark Goh from iTrust, and I'll be your MC for this webinar. And this will be the first of a few webinars that iTrust will organize around the topic of maritime cybersecurity. For those who are unfamiliar with iTrust, we are a research center in cybersecurity at the Singapore University of Technology and Design. And before we begin, iTrust would like to thank the Maritime and Port Authority of Singapore, MPA, and the Singapore Maritime Institute, SMI, for their support in this webinar. And here's the program for this webinar. Professor Jianing Zhou, Co-Center Director of iTrust, will give a short opening address. We will then have Mr. Noriyuki Kajita from Class NK to kick off this webinar by sharing an overview of the capabilities of Maritime Autonomous Surface Ships, or MASS. And Ms. Päivi Bruno from MESTA will talk about how standardization can help to push digital innovation in maritime ecosystems. We will then look at cyber risk assessments specifically for autonomous maritime systems. Dr. Victor Bobot from Aalto University will share some of the challenges and opportunities in this domain. And finally, we have Matti Sominen from Wärtsilä to help us look into the future of maritime cybersecurity. After a short break, we will then open the floor to take questions and feedback from the audience. Prof. Zhou will then close the session by summarizing the discussions and the presentations. So without further ado, it is my pleasure now to invite Prof. Zhou to give his welcome remarks. Prof, please.
Thank you, Mark. Hello, everyone. Welcome to the webinar organized by iTrust. iTrust is a cybersecurity research center in SUTD, focusing on cyber-physical system security to protect the critical infrastructure. Maritime is a key sector in critical infrastructure. Today's webinar is the fifth webinar in the series of maritime cybersecurity organized by iTrust in the past 2.5 years. I'm happy to see so many local and overseas attendees at today's webinar. Those webinars are very useful to share our understanding of cyber risks in maritime industry and get valuable feedback to fine-tune the new guidelines we have developed for cyber risk management of shipboard OT systems. Our new guidelines not just identify the cyber risks of each shipboard OT systems and recommend the mitigation measures. We also define tiers of security based on the urgency of cyber risks and provide a checklist which can be easily adopted by ship owners and operators. Now we have seen the advent of maritime autonomous surface ships, which will revolutionize the shipping industry. However, the integration of advanced technologies into MASS will introduce new cyber risks. This webinar will explore the current and future cybersecurity challenges associated with MASS, including the capabilities of MASS systems, standardization, and cyber risk assessment. Today, we are very pleased to invite 4 speakers, Nori, Päivi, Victor, and Matti, to our webinar. They are from Classification Society, Standard Organization, Academia, and Maritime Industry, respectively. They will share their expert views how to address those cybersecurity challenges. Attendees are also encouraged to raise questions during the moderated discussion. Again, the insight from our speakers and the feedback from attendees will help us to develop the new guidelines for cyber risk management of autonomous ships that we are working on. Thank you. Hope you will enjoy the webinar.
Okay, thank you, Prof. Zhou. Next up, we have Mr. Noriyuki Kajita. Nori is an expert engineer at Class NK Digital Transformation Center. He was in the aviation industry for 35 years and has fulfilled several positions in regards to design engineering of aircrafts. Nori joined Class NK in 2021 as a core steering member of Class NK's MASS team to develop Class NK's rules on approving MASS. And in 2022, he published a contribution article titled Necessity of New Framework to Support Social Implementation of Maritime Autonomous Surface Ships as a co-author on Class NK's technical journal. So may I now invite Nori to give his presentation. Thank you.
And this is Noriyuki Kajita. Everybody calls me Nori. Thank you very much for the introduction, Mark. Okay, I will share my screen and start my presentation. Can you see my screen?
Yes, we can see your screen.
Okay. Okay, I'm going to talking about the overview of mass capabilities, also the application. As of today, there are many types of mass is developing, also the testing all over the world, especially in the Europe and Asia, including Singapore and Japan. But the autonomous, the relationship between human capability and the system is different between each application. I mean the partial autonomous to fully autonomous, it depends on the application. But all of mass system for navigation has the capability of data collection, including the on position, heading, speed, surrounding information, which means the other ships information, the other ship's heading, speed, and the location, and also the obstacles, also the health monitoring of ships itself. According to the collected data, system understanding the situation, then system going to decide how to do. Is it okay to straight or turn right or left or stop or something like that? Then system control the ship, controlling the power of the engine, control the rudder and other devices to safe voyage. I will introduce the two typical mass navigation types will be introduced. First one is the autonomous navigation capability built into ship. Ship's capability is the data collection, situation awareness, decision making, controlling by itself. But still, they need some data from the outside, GPS, AIS, weather, and etc. This data is coming from outside to take into the ship, and the ship collected the data. But usually, ship's capability for the sending their situation to the shore. And also the voyage monitoring on shore capability will be installed. Then ship after using these four capabilities, then they use voyage by itself safely. Next application is autonomous navigation capabilities are built into shore. We call it remote control. Ship has to collect data surrounding ship. Then they will send the data to the shore. Also, GPS AIS weather data will be transferred from the outside to the remote control center. Then according to the data, remote control center understand the situation and make a decision and send control command to the ship. Then ship is voyaged by the remote control center command in safety. As you can see, so many data traffic. They compare with today's ship. According to this system, I will introduce some kind of scenario of the cyber accident or cyber incident. Then I showed up the just 3 cases, but so many cases will be taken into account. First one, the incorrect ship control by fake data, position weather, and etc. This slide shows the remote control center type. Then ship will send their data. Also the GPS, where the other kind of data is coming from. But somebody will change this data for the fake. Data will transfer to the remote control center. This is the bad data. But according to the bad data, then remote control center will understand the situation and make decision and send control command. Then ship lost his way. Maybe the collision will be happen. This is a very worst scenario, but we have to avoid such a kind of accident or incident. As of today, IMO doesn't provide any kind of cybersecurity guideline for the autonomous ship. This is a little bit different topic. The schedule of their rule making. Above side is IMO, therefore the international. They will issue non-mandatory guideline, maybe the middle of the 2024. Also issue the mandatory code the beginning of the 2025, but this code will be effective on January 1st, 2028. Bottom side is just an example of the Japanese for domestic voyage. Today is our plan. Maybe within the 2025, social implementation of MAS is planned. Compare is the IMO schedule and the domestic schedule, the 3 years earlier than the compare with the international and the domestic. Then just a summary of my presentation. Many MAS are developing and testing all over the world for aiming for their social implementation. Domestic social implementation will be earlier than international social implementation. But the risk of cyber incident is the same. Then the cybersecurity requirements for MAS, the autonomous ship, are required as soon as possible. This is my opinion. Then I need a shift left. Because cybersecurity incident will happen and have to mitigate minimum damage. Then everybody hearing this session and contributing creating the guideline for the cybersecurity requirements for MAS, then it is great support to provide a new requirement as soon as possible. Thank you very much for your attention. Then if you have some kind of question, I will accept maybe after everybody's presentation. Thank you very much.
Thank you, Nori. Yes, we will leave the Q&A to the end of the presentation after the break. We now invite Ms. Päivi Bruno. She is the Managing Director of METSTA, or the Mechanical Engineering and Metals Industry Standardization in Finland. METSTA is a sense maker with a pragmatic and holistic approach to standards and cybersecurity. And Päivi wants to help companies to discover how standards and cybersecurity can be leveraged as an accelerator for digitalizing industries and to foster innovation. She leads a team of professionals coordinating the national work in the field of mechanical engineering and metals industry, building automation and energy management standardization, both on the European and international level. And Päivi is a member of ENISA ad hoc working group for cybersecurity awareness and education. She contributes to the creation of industry standards and is finalizing her thesis for a master's in autonomous maritime operations. So Päivi, over to you.
Thank you so much, Mark, and thank you everybody joining this session today. It's really a pleasure to be here. So I'm going to share my screen with you and let me know if it shows nicely and we can continue.
Yes, we can see your screen. Thank you.
Thank you. So autonomous maritime operation is in really exciting phase. We are now coming closer to these viable commercial solutions, and a lot of the things are taking its place. There are still some biases and hindrances and roadblocks, and I'm going to talk about today how we can take them away and fully support the innovation in the industry. So maritime operations is always adapting and evolving. We can see from 1782, the mechanization, water and steam power. Then we leveraged the assembly lines and electricity. In 1969, automation and electronics and computers are helping the industry. And currently, we are leveraging the digital transformation, having the cyber-physical systems, thinking about the cloud. So tomorrow, why not commercial autonomous functions? But what does it mean and what do we need to have in order to get there? And trust. For any of these new engineered solutions, people in the industry, in the shipping and on the ports and the whole ecosystem, we have to trust that the autonomous systems are safe and secure. And if we take figures from the latest World Economic Forum Cybersecurity Outlook, 36% of the organization trust that they can actually sustain a cybersecurity attack. And then over 90% of the leaders believe that their organization will suffer some kind of cybersecurity attack within the next 2 years with a long-lasting impact. So we see that different kind of risks are impacting the system. So how did we approach this in the maritime industry? So we started to have these guidelines and regulations coming from the industry. 2010, the IAX published the first release of the onboard use and application of programmable electronic systems. 2016, 2017, 2019, busy years. We saw a lot of guidelines from the classification societies, from NK, for example, in 2019 and 2020. These were the efforts from the industry to help with the regulation and to improve the cybersecurity posture. And let's look a little bit, 2021, which was a major year in the maritime cybersecurity. The IMO resolution came into effect. Everybody knows that we now need to follow the cybersecurity risks in the risk registers, also on board the vessels. But look what happened in Europe in 2022 and coming to effect in 2023. We see a lot of European level, European Commission regulation impacting the AI, cybersecurity, the AI liability directive, the EU digital markets are coming into effect in May 2023. And then we have the EU Data Governance Act, which is applicable from September 2033. So these are all the regulations that are impacting industries and companies who want to sell their innovations and solutions to European-based customers. So a lot of things coming to our direction, how to make sure that your services and products are actually on par with the regulation, that you can enter the market. A lot of things happening here impacting also the maritime autonomous solutions. Coming on 2024, the new IAX requirements 26 and 27 are coming into effect. So these will improve the cybersecurity posture for new built vessels. So a lot of different kind of requirements are in this slide if you think from the developer point of view. So how should organization get ready for this? You have to be able to prove that the solutions are valuable and safe. safe, like we did discuss. So would you take all of these hundreds of requirements and put them into your backlog for developers to implement into your solutions? I'm not sure. Maybe we need something else. If we take, for example today on collision avoidance, there is no standardization or agreed way for a company to decide how to implement collision avoidance in your autonomous solutions. Is it something that we would like to leave on the working board of a development team or individual companies to decide? Maybe not, because these are the key elements for the safety and based on the liability, we have to get it correct. So a lot of collaboration can happen in the industry field. And this is where the standards are actually coming in. So through the standards, you can actually use them to support your cybersecurity work. You can leverage them in setting meaningful measures and maintain comparability between yourself or your competition or in your supply chain. You can use the standards on deciding how you want to identify threats and manage risks. And what is super important is that you need to select fit for context standards. What are applicable to your domain, to your customers? Because we know there are hundreds and hundreds of standards, and making the right selection is super important. But when you do, you can actually gain competitive advantage through certification. In some cases, it could also be like permission to play. If you are not fulfilling certain type of standard, you maybe are not able to enter the market. Or in some cases, it is a way to accelerate your own innovation. If you somehow get the innovation part of the standard, what better way would you have to leverage it in global level? For example, in Europe, we have the system where over 30 countries are implementing the same standards at the same time on European level. So there's a lot of impactful ways to contribute. So talking a little bit about the context, I selected here some standards that are currently supporting the maritime cybersecurity. Most of us are probably familiar with the information security management standard ISO 27001, but in the same family, there are some other standards that are actually quite good and you can benefit from. 2705, information risk management, business continuity, an important topic. We all know that we have to be resilient and ready to recover from possible cyber attacks or new scenarios, because we can't manage risk into zero. Something could always go wrong. So business continuity and resilience is then helping you to regain your momentum. What should you do if you have an incident? Of course, there's a standard to help also with that. And there's a nice standard 27036 for helping you on the supplier relationship. And something I want to highlight here is the privacy engineering side. So when we go into these maybe more intelligent, more digitalized system, maybe leveraging CCTV cameras or things like in monitoring, we have to start considering also the privacy aspect. And privacy engineering can get really good references from the ISO 27701 standard, which is sort of like an extension on the 27001. So these are frameworks from your business point of view. But then I want to highlight especially one of the key standards on cybersecurity on the critical system, IEC 62443. This is a series of standards helping you to improve your cybersecurity from component to solution to system level. And you can select which extensions you are certifying against depending on your role, whether you are OEM or whether you are vessel owners or different kind of roles. This is not the maritime only standard, but it is well adapted in the OT side of the things, so the critical side of the things. And then, of course, we have the NIST standards stemming from USA. They have a similar type of standards for risk assessment, supply chain management, and how to secure industrial control systems. So depending on your market, where you are, where your customers are, you have a different kind of standardization bodies who are operating and creating the standards. And I want to highlight here an example from last year. ISO 8102-20 is the first ever standard for cybersecurity to escalators, elevators, and moving walkways. And this is a real example how industry came together and created a standard where safety goes first, along with the security. It is based on the IAC 62443, and it has elements from the safety side. And what's really exciting about this standard is that it is customized together with the industry, with the companies, and they have created this really interesting function-based approach. So you can actually start to implement based on your functions. And this is something that I think the maritime industry could benchmark for, because currently the discussion around autonomous operations is also moving towards function, that you start to have more autonomous, more automatic, more robotic functions. So something to check out. And it's a pretty decent standard too. And how should you identify? What should we do? In the maritime ecosystem, the industry should identify these gaps and prioritize initiative for standards. Standardization is or should be driven by industry, because the main rationale why we have standards is to ensure good quality, interoperability, and ease of use for users, for example. So the good standards are created for a need. And if we work together in the ecosystem, I'm sure there can be different kind of initiatives identified. So how do you participate then in the standardization work? So here's an example of two ISO technical committees that are relevant for the maritime industry. The technical committee 8 is around ships and maritime technology. And then the joint technical committee 1 is 27 is around information security, cybersecurity, and privacy protection. The ISO standards are global. So not only European or not only on Scandinavian level, but they are global. And IMO is part of this group for the technical group 8. And the industry gets to participate through a national standardization body. So in every country, there is somebody, some organization who is taking care of the standardization on the national level. So you can join these groups, you can contact that coordinating body and get involved. So here's an example from this year on the technical committee 8, ships and the maritime technology. There's a lot of work ongoing, over 400 standards published, 84 standards ongoing, 27 participating members, and 22 observing members. And standards are really preparing for the future. And creating the standards does take some time, because we have to have consensus. There has to be consensus what we want to achieve. An average is 2 to 4 years, but sometimes it can take longer. So that's why different kind of technical committees are established well in advance. And some of the important things I want to highlight for the maritime industry is related to vocabulary, so that we would understand, for example, the autonomous in the same way, because in the past we may not have had the shared understanding. And I'm just quickly showing here a recent listing from the ENISA, what's there in front of us, what kind of threats there could be in 2030. And I want to point out that the supply chain compromise is high on number 1. And we know that the maritime ecosystem is the backbone of the global logistics and the global supply chains. So this is definitely high on our prioritization. And to conclude, I just want to say that in the maritime cyber, we have to know what's happening today, but we have to be also ready what's coming in the next decade. And you can influence that by participating on the collaboration, either in the seminars or standardization work. I want to thank you and looking forward for the questions at the end.
Thank you, Päivi. Now we have Dr. Victor Bobolt. He is a postdoc researcher at the Research Group on Safe and Efficient Marine Systems at Aalto University. Victor has a doctoral degree from the University of Strathclyde, Glasgow, Scotland, and an MSc degree from the National Technical University of Athens in Greece. And during his studies as a master and PhD student, Victor has received multiple awards for his outstanding performance from distinguished organizations such as DNV, Imares, Limats Stiftung, Tomaidian, TRA Visions 2020. Victor's research interests focus on design, educational aspects, safety, and cybersecurity assurance of complex and autonomous marine systems. So may I now invite Victor to give his presentation. Thank you.
Good time of the day, ladies and gentlemen. Thank you, Mark, for this introduction. Today, I will make a short presentation on topics related to cybersecurity risk assessment. So, I will just present a short introduction into the topic, and will present some cyber incidents in the maritime. Then I will present the general issues and problems related to the cybersecurity risk assessment. And after that, I will present some ideas on how we can address the issues related to cyber risk assessment in autonomous ships and in ships in general. So first things first, as we know, the first computer was designed in the 40s, but some researchers claim that the Antikythera mechanism, which was designed 200 years before the new era, is constitute the oldest example of the analog computer. In the 50s, in the previous century, we observed the first attacks that occurred in some experimental facilities. We also observed the first examples of ethical hacking, the first malware, the first antivirus, and the first legal prosecution for malware development. Starting from 1980s to 2010, we observed a rapid development in the cybersecurity area, which was due to the development of internet and commercial cybersecurity and exponential growth in attack vector. In the last decade, we observed that cybersecurity attack can happen not just on computers which are disconnected from the real world, but they can influence the cyber physical systems and industrial control systems. In the maritime, we observed such cyber attacks like GPS jamming or spoofing, malware infections, attacks on all terminals and infrastructure, attacks on ship operating servers, and so on. We are also entering a new era where autonomous ships are being designed and being operated. So around the globe, we observe that multiple test cases has been developed in autonomous shipping. And just a few days ago, we observed that Yara Birkeland sailed for the first time in autonomous sailing mode. So how does this new developments and the increase of cyber attacks affect and influence the cyber risk management and cyber risk assessment? As we all know, ships are assets which are designed to last for quite a long period of time. The typical life period for a ship is 25 years. And it means that essentially we can have very obsolete system on ships. So you can encounter ships nowadays which are running on Windows 7 or even Windows XP. And these are not supported IT systems. This renders these ships very vulnerable to cyber attacks. But also, it complicates the risk assessment because we cannot predict all the potential attack scenarios that can occur on ships and also autonomous ships. For instance, recently we observed the development of GPT-4, and some of the hackers have already used it to develop some intricate phishing attacks. So we are talking about very rapid developments in this particular area and evolvement of novel attack types. Heterogeneity of ship systems is another big challenge because we use multiple system providers on ships, and integrating them cybersecurely can be quite challenging and difficult. As we are having more interconnected ships, we are also opening new gates for cyber attacks on the ships. And in the case of autonomous shipping, that's going to be even more complicated due to the increased vector of attacks. In autonomous shipping, we also have more decision-making capabilities implemented by the systems. And this means that it will be much easier for a hacker to implement an attack on this type of ships. And more attacks can happen, actually, which would jeopardize safety. There's also less potential for human intervention in that cases, which means greater control by the hacker. With respect to the organization, we lack widely acceptable risk acceptance criteria, which complicates the risk assessment and comparison of different risk assessments. We are short on data with respect to what type of cyber incidents are occurring. And there are multiple reasons for that, but one of them is shipping operating companies concerned for their publicity and for their reputation. So they are kind of very reluctant to disclose any type of information related to cyber breaches in their companies. There is a collision between transparency, which is required by safety and cybersecurity. Safety is better ensured if we have transparent procedures, but cybersecurity might require hiding some of the procedures. Also, we are lacking entities which would support the gathering of all this cyber incident information. There's a need to advance the research in the cyber resilience area. And sometimes small companies, they are lacking resources to address all the issues related to the cybersecurity, which complicates the matter. Humans always constitute the weak link when it comes to cybersecurity because they can be easily manipulated. And so far, most of the cyber incidents in the market is exactly because of that. And environment is something that does not facilitate the cyber risk management because ships, they change ownership quite often. And it means also that the change of ownership should be properly addressed in the maritime. But just concluding this section, we can say that for the time being, most of the cyber incidents, they are related on IT systems, and they can have various consequences from small to large, but they do not compromise safety. And we also had quite a few incidents which compromise safety, but not to a large extent. We should not be assured by the statistic for the time being, as the area is rapidly evolving, and we can have also cyber incidents which would have catastrophic scenarios. This is well described in Zepero's book on normal accident theory, where he can describe how low likelihood, but potentially catastrophic scenarios can occur. But of course, we also should not be paranoid and should not be very concerned about what is happening in the area. Just in case you want to get entertained in a useful manner, you can also watch this film called Speed 2 Cruise Control. This is a film which was launched in 1997. And again, this film actually describes some of the potential cyber attacks that can occur on ships. Now, how can we address the arising cybersecurity issues in the conventional shipping, but also in the autonomous ships? Most of the issues can be actually very easily addressed. So by implementing something of like 20% of the effort, 80% of the issues can be addressed. This is an approximation of well-known Pareto rule, which describes exactly that most of the issues can be addressed actually by very little effort. In the autonomous ships, this is more complex because of a lot of unknowns, and this means that we need to provide more resources and implement more effort to address the unknowns in order to be safe. And this actually means that we need to implement more effort, and we need also to do that in dynamic fashion, considering the evolution of the cybersecurity area. Since more attacks are being implemented, it means that we need to be always alert and to be ready to update our procedures and our risk assessments. Now, going deeper into that, we have implemented a review study on the different methods that are currently implemented by the academics in the maritime with respect to the risk assessment. So what sort of methodologies they use in order to identify and manage the risk in ships. The main methods are classified as in this figure that you can see. So essentially, the academics so far have either borrowed methods from the safety area, and they have advanced them so that they are fit for cybersecurity risk assessment, or they took methods from cybersecurity and they adapted them to the ship management problem. But some other academics, they developed model-based approaches, which in their opinion, and also in my opinion, are more fit for the problem of addressing cybersecurity issues. And why do I believe that? A very popular method on cyber risk assessment is STPA, and it has been implemented in the case of autonomous ships quite often in the research studies. It's a good method to identify some emergent issues and scenarios, and to consider also the socio-technical structure, and also to identify some attack propagation paths during the cyber attack. However, it's very complex and resource-intensive method, and it's not directly related to the cybersecurity problem, so it needs to be advanced further. We also have methods like STRIDE, TREAD, OWASP, and FMEA and HAZIT, which are very simple methods, and they can be easily applied to the maritime systems. This method can be used to identify this 80% of the issues. So essentially, if somebody applies them, he can claim that he addressed most of the issues, but this will not be enough, especially in case of the autonomous ships. So more methods should be used, like FTA, attack trees, MITRE, and secure tropos probably, in order to identify the issues in autonomous ships. These methods are good because they are easy, and they are good for reporting and for getting approval from class societies, but they are based on the experience of personnel. They are difficult to update if new cyber attack scenarios are identified, and they are not so cheap, because you always need to involve some personnel hours in order to implement them. On the other hand, model-based approaches, they are much easier to reassess, but they are reliant on a proper abstraction and interconnection to other methods in order to be effective. So another way to improve the cyber risk assessment is, of course, to use the statistics, and developing a platform for anonymous report incidents reporting would be very helpful. But I believe that this still will not be enough for cyber risk management due to the nature of the area. Since more attacks are being evolved and developed, we need to consider motivation, resources, easiness, and opportunities for different cyber attacks. And that's why I consider very important to include in the cyber risk assessment also the potential system unknowns and potential aleatory unknowns. More advanced cyber risk assessment method could be based on game theory, prey-predator algorithm, and immune system response algorithm. Another way to be more dynamic is also to develop some algorithms and approaches which will be updating the risk assessment in real time. Considering that we might not include all the potential scenarios during the cyber risk assessment, cyber resilience is becoming more important, and it's always important to ask such questions like, okay, we get hacked, but what should we do next? And also the development of risk acceptance criteria, that's a topic that needs to be addressed in the future to allow comparison of the different risk assessment implemented by different operating companies and different researchers. But this is more related to the fundamental of risk management and risk assessment, and it should be implemented on academic level, as I believe. So, concluding my presentation, cybersecurity is a really dynamic realm, and novel attack scenarios are being constantly developed, and we should be constantly alert. And challenges for the cyber risk assessment on ships and autonomous ships stem from the ship design and ship's lifetime, the processes, the humans' capabilities to address all these issues, and the environment. We see that cyber attacks are currently occurring mostly on IT systems, but OT systems can be also hacked. And we should also develop some control measures for this type of attack scenarios. And there is a need for novel types of risk assessment techniques, which would be interconnected with some databases of vulnerabilities and potential attack types, which are based more on models and consider better the uncertainty and the potential uncertainty in the likelihood of the cyber attack scenarios. We also need to provide greater emphasis on resilience, and we also need to address some fundamental issues in the risk assessment in the maritime. Thank you very much for your attention, and I will be able to provide an answer to any question that you have during the Q&A session. Thank you.
All right, thank you, Victor. And last but not least, we have Matti Suominen from Wärtsilä. Matti heads the cybersecurity activities across Wärtsilä's marine product and service portfolio. He has a background in cybersecurity and product development, and outside of work, Matti is an active participant in the cybersecurity community. So let me invite Matti to give his talk. Thank you.
Thank you so much. Let me share my screen and we can get started on this one. So I'm going to be talking about some of the points that were brought up and can hopefully provide some commentary from our side. Just a quick mandatory disclaimer to start with. So I'm mostly speaking on my own experiences today. So not necessarily giving the Wärtsilä view on everything. So just wanted to give that out as a mention before we get started. I'm sure there's a lot of opinions into whatever comes into the future. But as mentioned, Matti Suominen, director in Wärtsilä, and working a lot with the different marine product portfolios. And we have basically products across the whole marine space. So if you were to build a autonomous vessel in future, it would almost definitely have some equipment from one or more of our product lines. So therefore, this discussion is definitely quite relevant and interesting to us. Let me jump into a couple of points here. So first of all, thinking about the past first, a couple of the colleagues were already talking a little bit about what was the history in this field. And definitely cyber wasn't so much present in there. So Victor was mentioning that a lot of the old systems are using old obsolete technology. That is definitely true. If you go 10, 20 years in the past, there wasn't really that much in terms of cyber requirements. So a lot of this is actually rather new developments. We are now seeing the IX rules come into play. That is maybe the first time that you see such an extensive list of technical cyber requirements. In past, a lot of it was documentation, processes, etc. So not so much of it was actually touching the equipment itself, the things that we put in there. And surely enough, I mean, the processes and the documentation do play a role in cyber, but also the technical part of it. So if we are talking about hacking and this kind of technical attacks against the systems, we are definitely talking in large part about how the actual systems are designed, what kind of safeguards are put in place, how do we implement them in such a way that they would be as difficult as possible to attack. So that's kind of the history of this. And you have to think about it from the perspective that whenever there's a new piece of regulation or a standard or something that comes out, it is not like we recreate all the products from scratch and start from nothing. So a lot of the products we are making already today will be seen in some way, shape, or form also in the autonomous vessels of the future. Because if you think about something like a navigation system or automation systems or engines, those are not typically developed in a year or two. So if we develop something brand new today, it is going to see the light of day in anywhere from 5 to 10 years, maybe. And from that point on, it's going to live a life cycle of 10, 20, 30 years in some cases. And it will be found in a lot of vessels much beyond that. But as mentioned, today we are getting to a point where we do finally have cyber requirements. We are finally getting to the point where the owners and the yards and other players and the OEMs, of course, are finding that, hey, cyber is actually relevant in this field. We need to do something about this. We need to make our products secure. We need to install and connect them in a secure way. We need to think about how we operate the vessels. So this is definitely making life complicated already. And the moment you start adding the autonomous part into the mix, it gets even more interesting. Because if you think about what really changes, so a lot of the systems we have today, a lot of the things that, for example, Wärtsilä is providing are the key systems that are needed for the autonomous operation. This was already mentioned earlier in the first talk that there are systems like navigation systems, there are a lot of sensors that are really critical for autonomous operation. Today, you might be getting pictures from cameras, you might be getting feed from the GPS and other systems that is then given to the people, the actual humans on board the vessel, who then make the navigation choices and can judge whether something is right or wrong. But as we move forwards, we will see less and less those people in the mix making those calls, and we will see more and more systems that slowly but surely will more autonomously make those decisions. Colleagues were a little bit alluding to the whole discussion around how autonomous isn't a yes or no question. It's not a question of today we are not autonomous, tomorrow we are autonomous. It's more of a gradient where today we are somewhat autonomous. We have a lot of decision making done by machines already. Tomorrow we might be more and more there. And as time goes by, we will see more and more systems becoming autonomous, partially, fully, whatever the change is. So it's good to think about it in that sort of terms. We are not going from no to yes, we are going from a little bit to a bit more and then a lot more and so forth. So the cyber needs to be built there over time. We need to think about what is happening in the future. I was mentioning this already in her presentation. I think it was a good point to repeat that we don't have a lot of requirements and guidance today for what an autonomous vessel needs to be, especially on the cyber front. We are starting to see what it needs to be as a vessel. How can we run one from functional perspective? But we don't fully have a clear picture yet for what the cyber needs to be. And that is especially a challenge for us OEMs because we need to understand upfront what are we actually building? What is the market looking for? And you see this kind of challenge with every single regulation and set of requirements and best practices that comes out, because we're always a little bit changing or chasing a moving target where today the requirements are something, but then in future they are going to be something else. And therefore we need to be taking part in that discussion to understand what the challenges are in future, what we need to be prepared for. Because again, what I mentioned earlier, so if you're building an engine today, and you are building the engine control system and you're implementing the cyber controls in there, if tomorrow somebody comes out and says, hey, we actually have new requirements for cyber because we have identified all these threats in future, it is going to be really difficult to implement them overnight and start shipping new engines all of a sudden. So we want to really be on top of what is happening and understanding what the future will bring. So thinking about the autonomy in particular, it will create a lot of new challenges to us, not of course only to us, but we will be definitely playing a key role in there. One thing that I think is going to be changing quite a lot is the importance of a lot of the systems that we already have today, but they may be supporting the crew, they may be providing valuable input, they are making it easier for the crew to operate the vessel, but they are not necessarily today operating the vessel on their own. So take, for example, a navigation system or any of the sensors, cameras, what have you, that are on board most vessels today. So today they are supporting, they are helping, they are giving valuable input to the crew. They are telling them what is out there. They are talking about these sort of things. But it's not necessary that they are absolutely mandatory in many cases, or there's a lot of different ways that the same information can be conveyed. And also the crew can basically help those systems. They can do what humans are really good at doing. So they can look out the window. They can most likely see if the sensor input is absolutely not matching their expectation of what it should be. If the vessel is suddenly moving from one location to another and the crew is inside the vessel, they can say that, well, that definitely did not happen. So we humans are quite a bit different to how computers work, in that we think very differently. Our brains don't work in the same way as the systems do. So if there's a problem that is uniquely affecting the systems, it very well might be that the crew is completely unaffected by that challenge. So we can always ask somebody to check things out. They can use their intuition to pick up some things. They can start digging into why something might not be working. Now, from cyber perspective, this is actually even more important because humans are, as said, often unaffected by the things that might be affecting the equipment. So when there is a cyber problem, it is actually much easier for the humans to be there supporting, and we don't need to have the same capabilities to support them. They can completely independently, without any connectivity or anything else, they can go and check out something. And they can verify whether it's working as expected, whether they need to start using something else, what inputs can they actually rely on, and so forth. This changes quite dramatically when you introduce cyber attacks into the play, because even though we already have today a problem where sometimes sensors don't quite work as you would expect, or systems might be going down, but those are typically random occurrences. Something breaks down, something doesn't quite work right, and you can usually tell when it's not working right. You get values and you get input that doesn't really make a lot of sense, and then you can compare that to how the reality looks like. But cyber attacks are a bit different because now you might have an attacker that is actually looking to do something very deliberate. They are trying to be as hard to detect as possible, whereas random problems on the equipment are typically not doing that. There's no intention, there's no human being thinking about how do I best make the system misbehave. That is again a challenge for a lot of these systems that were not always designed to withstand the kind of attacks where somebody intentionally and deliberately tries to make them misbehave. So something like the sensors, for example, need to do a lot more to make sure that whatever data they are providing is actually legitimate, it's genuine, it cannot be altered. You cannot basically cheat the system in that sense. Victor was talking a lot about the threat modeling and how do we identify these sorts of scenarios where somebody can potentially make a system misbehave. So those threat models change quite a bit when you introduce autonomy in an increased manner. So as the system starts to get more control, those things really need to be bulletproof from the technology perspective. You cannot really rely on something else picking up the slack and hopefully helping you the rest of the way there. The other part I wanted to mention is the connectivity, which was already mentioned a little bit in the earlier presentations. So as we start moving more and more towards autonomy, the connectivity becomes really crucial in many ways. So again, when you have a lot of people on the vessel, especially some of the larger vessels like cruise ships, for example, you have a lot of crew there. Many of them are quite capable of doing a lot of the work on the equipment. But as you start taking away those people and you start replacing them with machines, you suddenly face a challenge where if something goes wrong, either the system needs to recover itself and somehow fix the problem on its own, or you need to get a human being involved. And you can imagine as you start taking people away, let's take a hypothetical scenario where there is nobody actually physically present on the vessel. So now you are facing a challenge where the connectivity really has to work. You have to be able to remotely connect there. You have to be able to remotely diagnose based on the input you're given. Whereas nowadays, a lot of the time, the connectivity is useful. Sometimes it is really, really useful, but it is typically not absolutely mandatory. So we build everything expecting that connectivity will be there sometimes and maybe not at other times. So that's perfectly fine. But as we start adding more and more of these capabilities, we run into a scenario where, again, this is something that really just needs to work. Otherwise, we are facing problems. Jumping into cyber incidents and a little bit based on all of that. So if some of you may have been in a scenario where there's a cyber incident on a vessel somewhere out there at the seas. And very commonly when that happens, from practical experience, I can tell that very often these get detected by the crew. It might be as simple as, hey, I'm looking at my screen, I'm seeing really strange inputs. I don't know what this means. The screen is showing me something unusual. Maybe that's a ransomware attack. We can immediately tell that, hey, maybe the system has been taken over by a ransomware attack because the person next to the screen is seeing a ransomware node on the screen. Great. So now we know what has happened. We have a person next to the system that can, pull out the backup. They can move to a secondary system. They can run antivirus on the system, whatever might be the right way to move forward. But at least we have that person right there ready to act on the problem. Or maybe they are seeing something less obvious than a ransomware case. So maybe it's just the system slowing down. They are seeing that previously something took this long and now it's taking twice that long. And it has been taking twice that long for maybe a week. Okay. So now we might be thinking that there's something again wrong with the system. It might be a cyber problem. It might be something completely different, like just system malfunctioning or some parts of it breaking down. But still, we have that person there who might be really qualified to work on those systems, or they might not be, but still they are capable of following instructions from the people onshore who can help them figure out whatever is going on. In some cases, we might be able to remotely log in. We might be able to do all these activities from outside. But in case we cannot, for example, the connectivity is part of the incident. So the connectivity is either not reliable, cannot be trusted, or we don't really know what's going to happen if we try to use it. So in those cases, we have the crew there to help us. This is again one of those scenarios that there can be any number of causes for a cyber incident. Victor already spoke about a lot of the possibilities there, but the real problem is that there is basically infinite amount of things that can go wrong in any number of ways. We can have multiple incidents at the same time that are affecting different systems. So it's really hard to predict what we need to be prepared for exactly. And that's where humans are really great, because we don't need to be told exactly what's going to happen. We can very often just improvise on the spot when there is a unusual situation going on. So that is something we are definitely losing more and more as we give the system more and more control. And again, we need to think about how to resolve those scenarios when and if they happen. So definitely an area where I think the autonomous progression will have an impact on. How do we make sure that we can fix whatever is going on at the vessel when and if it happens? So wrapping up my part, I think this is definitely a progression that is going on all the time. And for the next 10, 20 years, I don't know, let's see how it pans out. We will see more and more systems that are supporting the crew, taking away some of the tasks that they don't need to do, giving them more time to focus on the things that they are really good at and can provide the most value in. But it's going to be interesting moving beyond that and looking at the cyber requirements coming out as to what would be the right way to build a autonomous vessel, what would be the necessary components to make such a vessel secure. I don't necessarily think we have all of that together today. If you would take the IX requirements that are currently out, they don't talk about a lot of the themes that we are maybe worried about moving forwards. There's not a lot of focus on connectivity, for example, how to make that secure, how to ensure that it's available, and so forth. So a lot of the building blocks for autonomous operations from cyber perspective are definitely not there today. But I'm hoping they will be in the coming years. And I'm sure definitely, as Päivi was mentioning, it is the industry and it is us vendors that need to be aware. We need to be active in this discussion and making sure that basically the understanding and all the learnings and lessons we've learned over the years are taken into account while thinking about what the requirements should be. That is my short piece on the topic, and let's definitely keep the discussion going as we get into the Q&A part. Thank you.
All right, thanks, Matty. Our presenters have done very, very well today. Everybody has kept to their time, so we are right on time. We will now have a short 5-minute break first before the Q&A. All right, welcome back, everyone. Now we have the Q&A and feedback session. You can click on the Q&A button right at the bottom of your screen to ask questions to any panelists you would like, or you can even view the questions from other participants and upvote their question. So by upvoting their question, the question gets a higher priority and it will get pushed up in the list to be answered. And we already see some questions raised and also some questions that have already been answered. So keep it coming, and I'll leave the Q&A open so that I can see who has asked the question. So maybe for the first question for Class NK, what type of cyber incidents have you seen or experienced in the aviation industry that you think can also happen in the maritime industry? So Nori, this question is for you.
Oh, thank you, Ron, for asking. But to tell the truth, I do not have any experience about the cyber incident or cyber accident in aviation world, especially for the cyber attack aircraft itself. Also, the airport was attacked for their website only. But the reason is that as the commercial, we do not have any kind of autonomous aircraft right now. Still, pilots have a responsibility to operating the aircraft.
Okay,
Yeah.
thank you, Nori. Let me look for the second question. Could you please talk about the requirements that IACS E26 and E27 standards impose on ship operations? So I think that's for Päivi.
Yes, I can start, and maybe Matti to continue. These are the upcoming new regulations that will be put in effect 1st of January 2024. And E26 is more to the vessel operator. So you need to take care that the IT and OT systems in your networks are, for example, well segmented and different kind of cybersecurity capabilities are available. And the requirements are for new builds. what you order after 1st of January 2024. And then the second part, E27, is more about for the OEMs, how the different kind of third-party systems are secured and what kind of capabilities are present. And these requirements are heavily based on IAC 62443 and also some other industry standards. Maybe Matti, to you, how you approach this?
I can take it from there. Definitely correct on the, so E26 is the one you want to definitely read. And it's a little bit split between the yards and the owners. So there are requirements for how to design the interconnectivity between equipment. So that is in large part, I would say, to the yard to do. But then there's a lot of the operational pieces. A lot of the challenges we see coming from our customers relate to asset management, for example, understanding what they are having in the vessels, what sort of equipment, all the way from the big parts like the engines and such, all the way down to individual network switches and routers and what have you. There is a lot of requirements to patching. There is requirements to remote connectivity, and if you do remote service maintenance or those sort of things. So really, I just recommend reading the whole standard. It's not that long, so it will take you about 15 minutes to go through on a casual level, and then just kind of take it from there. And as Päivi mentioned, these are largely based on 62443. I think there was a separate question on that one. So if you have already been following some of these standards, there's a good chance you're already doing a lot of the mandatory things.
And something I really like here, that it's taking the life cycle aspects. It's not just ending when you get the vessel or deliver it, but it's looking for the future, which is really good and what we need.
Correct. And it's just good to keep in mind that when the vessel is delivered, it's important, of course, that it's secure at that time, but that vessel is going to be looking at 10, 20, 30 years of lifespan out there. So if it's secure at the time it's delivered, that's great, but really it's the 10, 20, 30 year mark that is going to make all the difference.
All right, thank you, Päivi and Matti. Another question for Dr. Victor would be, is AIS data encrypted and safe?
Well, just to answer it shortly, no, it's not encrypted, and anybody with a a receiver in the local area can also receive IS messages which are sent by the ships. So, and I think that's an intensive topic of research currently.
Thank you. Okay, I think there's a general question that any of the panelists can try to tackle. So for organizations where cybersecurity procedures are already implemented, how can they prepare for cyber attacks? So for example, currently vessels have various contingencies and drills to prepare their ship crew for various emergencies that may occur on board. So will there also be similar guidelines on such cyber attack drills? So this appears to be a bit of an IMO question, but feel free to tackle this. It could also boil down to individual ship owners taking their own initiative to carry out or prepare the seafarers for such drills. So I see Matti and Päivi would like to attempt to answer this question.
Päivi, you can start.
Yes, so I'm just quickly saying that practice, 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 and make it similar to your fire drills or something like that. Everybody in the vessel knows where is the fire extinguisher, what to do if there is fire, but just make sure that your crew and people know what to do, where to contact if you have a cyber incident. And personally, I think we can leverage more the partners and the vendors. So with this, I'll give a turn to Matti.
No, absolutely. That is exactly it. So practice is really key. And I think we sometimes make cyber a little bit too complicated. It's at the end of the day, it's like Päivi said, it's the fire extinguishers and the equipment on board the vessels. It doesn't matter if there's a safety problem somewhere, if there's a cyber problem somewhere. Just think about it the same way. It's a kind of a problem. We have certain procedures and we have certain contacts and we have certain experts that can help with that particular problem. basically writing it down, practicing it, making sure the equipment needed is available, and then also thinking a little bit about how we are going to recover. So do we actually have spare USB sticks available that are going to be clean? Do we have a backup of the system somewhere? All those kinds of steps are something you want to do before, because usually that's what we do when we have a problem, and then we start kind of panicking and trying to somehow resolve it. So that's not going to go well.
But also this is Kajita. There are some kinds of guidelines will be required to think about the training, especially for the content. Because there's some of the ship owners doesn't know about the cybersecurity in detail. It's very good for they publish some kinds of guideline, maybe the IMO or IAX or Plus Society or something like that.
Definitely.
All right.
And just a quick one to add on that. So the IAX that was discussed earlier, there's a lot of requirements there to document certain things that are also going to be helping during the incident. So I think once you meet those requirements, I think you're already well on your way to having the right pieces in place.
Okay. Another question could be a bit research, could be technical. Is there a minimum distance required to generate fake data for autonomous ship? So I would assume here that fake data could mean AIS data or GPS data. So I think the concern here is for the ship owners to see, at what kind of distance would a cyber attacker need to spoof all these data for autonomous ships.
But not only for the autonomous ship, but the GPS spoofing has been already happened. But I don't know the detail. Sorry.
Yeah.
Maybe if you think from the risk point of view, what kind of activities or operations the vessel is doing. So many of the expensive incidents or accidents can happen when you are in the port, for example. So if you collide with the pier or something like that. So in those scenarios, you could think that these kind of spoofings could be a big factor. But if you are on the open sea, there's nothing going on, how are the risks impacted? And I'm just briefly going to say that something very, very important to remember is that the AIS protocol is from an era where the trust was assumed. So that's why it's not encrypted or otherwise secured. And also the AIS data should not be used for something super critical because of this.
Thanks. Victor, you have something. Matty, you have something to add?
Victor, go for it first.
Thank you. Well, yeah, I would agree with Päivi, but actually the operating area is the important factor to consider here. For instance, for a ship that is just going from Helsinki to Tallinn, a difference in several decades of meters can be crucial because it can cause some confusion to the crew. But if you are in open ocean, then if you are even hundreds of kilometers, you're having hundreds of kilometers error in the ice position, that's not an issue. But again, it's exactly that we should not rely just on ice. But unfortunately, some accidents show that this has happened. People very rely on ice, and this has led to some very costly accidents.
Maybe just to briefly continue on that. So when you say distance to generate fake data, I think the crucial question is what sort of fake data. There are sensors that are cameras, for example. There you need to be close by to do something. There is data coming from weather systems that might be on the other end of the world. It might be a website somewhere or web service somewhere. You could have somebody remotely accessing the vessel to feed data into the system if they manage to hack their way in. So it's important to keep in mind that there's very different kinds of data coming from very different locations, and that makes a huge difference. So thinking in terms of distance or proximity is maybe not the best way to think about it, because different things are going to be vulnerable to different things.
Okay, one question for Nori. What is your view regarding the relationship between the degree of autonomy and cybersecurity?
And this is a very my personal opinion. If somebody designed full autonomous ships without the cybersecurity measure, it doesn't make sense. We do not allow to voyage this ship. I mean, the relationship between the cybersecurity measures and the capability have to be thinking. Then somebody told about the thinking about risk is a very good way to is good for the autonomy, the relationship between the autonomous capability and the cybersecurity measures. But some of the capabilities should be limited based on a poor cybersecurity.
Thank you, Nori-san. Let's see, another question for Payavi. What would you say to small and medium-sized companies or even startups on why they should participate in standardization?
This is my favorite question. I think it's for information to get started. So when you participate, you get to know what's happening around the standards, what's upcoming, how people are talking about the topics, and you also get to build your own networks when you collaborate with other people participating in the standardization. Then when your products are maybe more mature or when you are gaining more experience, you can also influence. So you can influence what is going to be a standard. How is that standard written? But for information and learning, that's a big thing.
Thank you. Okay, I see two questions here that are asked by different people, but I think I can lump them together. The first question is, do cybersecurity vendors are they required to get their products to be E27 certified? And a similar question to that would be that, if the main vendor is creating a certain product for the vessel that complies with this E27, but actually that product contains certain third-party elements, and those third-party elements do not meet the E27 requirement. So in that case, how can the manufacturer of such products then comply with E27? So I have lumped these two questions together.
I can maybe kick off on this one. Are vendors required to comply with E27? Well, sort of. Nobody's forcing you to comply, but obviously if you don't comply and somebody tries to buy the product, then that's not going to go well. So nobody's forcing Wärtsilä, for example, to comply, but then we want to keep selling the products. So in a way, yes, it is mandatory in a year. And on the question of the supply chain piece, so what happens if, for example, we sell a piece of equipment and it comes with other equipment that then is not compliant? So the way I like to think about this one is that if it was like that, so if I could sell something that is compliant and as a mandatory part of that product comes something which is not compliant, you can think about it in a way that obviously wouldn't work, because otherwise I could outsource everything to somebody else and claim that I don't need to be compliant because it's not my product. It is a contract between me and the yard, for example, where I'm promising to deliver them something, and I'm promising it's going to be compliant with E27. And if it's not, it doesn't matter whether it's my equipment or equipment from a network device manufacturer or something else. It is part of the delivery. It's what I'm selling to you. Now, of course, if you are buying that then separately from somebody else, that's a different thing. But that's contractual, essentially. So there will definitely, hopefully, at least be a contract with somebody who is providing that equipment, who is saying, yes, we will comply with this. And that is crucial for you to also make sure, if you are on the buying side, that you are actually making those agreements with the right parties, and you're buying equipment where the compliance is actually needed. The thing is, at the point where you put that in the vessel, so it's not that I necessarily need as a vendor to comply at the time of sale. I give it to you, you will install it, and then you will find out that it will be very difficult for you to actually get the certifications in place. So make sure you are actually agreeing contractually on this one.
Great. So basically a main con, subcon kind of thing. As a main con, you need to be responsible for, whatever your subcon is doing, because ultimately you are the one who is answerable to whoever you're selling the product to.
Correct. Somebody
Yeah.
writes their name into the contract, and that person, and hopefully the contract does say so. Just really emphasizing the point, make sure that the contract, when you are buying something, that you're specifying that it needs to be so and so. Nobody's going to necessarily do that due diligence for you, so it's perfectly possible for you to buy equipment which is not compliant. You just then end up with equipment that is not compliant, and that's not great for you.
Right. Okay. There's one general question, pretty interesting one. If there are terrorist attacks on autonomous ships or even, pirates, how do you then go about protecting the ships? So I think this question has the presumption that the ship is fully autonomous. There are no man, crew, or, even armed personnel on board. So not exactly a cyber question, but if anyone free to take it up, I see Victor has held up his hand.
Yeah, it's a kind of question very similar to the film that has been created, the Speed 2 cruise control. So you can watch that as to get some ideas on how a terrorist attack can happen. But in case of the autonomous ship, in order to control that, I believe that some remote control should be available, so that you just switched off everything on the ship and it's just become a barge. And there must be also some security measures in place against pirates, so that nobody can board and access the safety and cybersecurity critical system on the ships. That's what I would expect to happen on the autonomous ships. But this refers mostly to unmanned ships, not autonomous ships, because we can have also autonomous ships, but with the crew, and that's different. Then the crew can just intervene and can prevent or mitigate. Thank you.
Yeah, Päivi?
Yeah, such an interesting question. I think there should be this kind of scenario when you think about, when you design these solutions in a way, the worst case scenario. So I would expect there to be some sort of a safe state, that different kind of sensors, or for example, again, that CCTV camera, they operate a little bit differently. So depending on the risk level, you could actually also impact how your vessel operates. Think about the Tesla cars, for example. So with the software update or software feature, you can change how it operates in certain conditions. So a little bit of fantasy movie thinking here, but something like that. Matti.
Yeah, just a really quick one. So then, of course, it's a question of why are the terrorists on the ship? Are they, normally it might be that they are trying to kidnap somebody or whatever it might be. Well, the less people there are, then the less of a problem we have. If they are there to steal whatever is on there, I mean, again, Victor already mentioned that you can then always just turn off the vessel. Is it possible to even for them to navigate it on their own? So it's really a question of what are we actually discussing? Are we discussing kidnapping? Are we discussing theft? Are we discussing something else? And I think that's sort of where you have to start the thinking from.
Right, thank you. Since we have you, Matti, so there's a question. You mentioned in your presentation that, generally human beings think differently from machines. And during a cyber incident, it can sometimes be easier for humans because they are already on the ship so that they can verify the situation and decide what sort of actions to take. And so with that, it seems like there is still some value for humans to be on board the vessel. So, how then do you see the future of maritime autonomous surface ship would look like?
That's a really good one. So this goes, I think, less about cyber, more about AI development in future. I think today it's rather obvious that if somehow we could make the equipment we have right now there, if we could make that autonomous somehow, we just take the people away and we let the equipment run the show. I don't think it would go very well from cyber perspective, because a lot of the equipment isn't able to necessarily detect that it's being attacked by some sort of cyber attack. Even if it was able to detect that, it cannot necessarily do much about it. It can try to protect itself, but the moment you compromise the system, it's usually game over. So from that sort of way of thinking about it, the human is really nice because humans are very different from machines. So any ransomware you throw out there, it's not going to compromise the people on the vessel. it is a really good question that for how long is there going to be a need for a human there? I'm being told by all the AI people that at some point the AI is able to do so much more than people are, which is fair. I mean, you could argue that there's going to be a robot that is going to be doing all the same things, and it's much better at figuring out what can happen and how to diagnose that. So this goes, I think, into the realm of what happens in 50 years. Is AI going to be so much smarter than us that we have no place in the vessel? I don't know. I'm not an AI developer. All I'm saying is that for the next, I don't know, 10 years, I'm somehow not seeing that happening, especially with the existing equipment. Who knows what the future will bring?
Ivy?
Thank you. And maybe not just equipment. I mean, I like going to holidays with my family, and we love to go to cruise ships. I mean, I want to see the entertainers, I want to meet the crew. So I'm not looking in the future or thinking about future where all the vessels would be unmanned. So for example, I think it's a scale. So highly unlikely that the vessels like cruise ship would be without humans. But then if we go, for example, these container barges who go on the similar route day after day or multiple times at the day, not very exciting. The environment can be well predicted. There, yes. So the scenarios are different. I think there's always place for humans. I don't want my avatar to go on holiday instead of me.
All right, good. And one question for Nori. When will the new cybersecurity requirements for MASS be required? You are muted, Nori.
Sorry, that's a very good question, but some of the Japanese ship is now in the designing stage that they are worried about what kind of cybersecurity measures have to be implemented. Then, in my presentation, I asked everybody to do as soon as possible, but maybe it takes a year or two. But 2024 may be the good point for Japanese people. It looks like it doesn't look like a good answer, but I need as soon as possible.
Okay, sure, no problem. Thank you. Let's see. Another question for Pivy. Is there any way that, I think for ship owners to prioritize implementation of the standards, given that there are quite a few out there, E26, E27, IEC 62443. So I think, yeah, is there any way to prioritize the implementation of these standards?
Definitely, I would go and check the IAX 26 and 27 first, because they are greatly based on the IAC 62443. So, and it is industry relevant. It is created by maritime people for the maritime industry. So starting from there. And then I think you are well covered or getting there. Matti.
Yep, thank you.
If I can really briefly just follow up on that one. Definitely so, and just keep in mind that it's not like these are different standards. I mean, the requirements are largely the same, phrased in different ways. Some of them have more, some of them have less. So if you already looked into 62443 for your equipment or your operations, then you're most likely already quite far there with the IX requirements. And DNV is largely mapped nowadays to the IX requirements as well. So again, you are largely done. What is really useful is to have some way of mapping these in your organization. So you understand that when I'm doing requirement 1 from DNV, I'm also doing requirement 1 from IX and so forth. So definitely have that in place, and then decide based on that which ones do you need to meet first and what are you actually already meeting, because you might be surprised when you start looking into this.
Right, thank you. I see one question that was previously answered by Pivy, but also another person is asking, I think it's the same question, which is how to join the various technical committees. So for example, ISO TC8 or ISO IEC JTC. So previously, Pivy answered to this person to contact to identify your local standardization body. So I think this would answer the one that is currently open in the Q&A box. So one question for Matty. Up to what extent are you using AI to develop cyber prevention software for autonomous vessels?
Yeah, I love this question. Yes and no. So definitely, if you think about how a lot of the technologies work that we are using, different sort of antivirus monitoring, etc., all of these are based on some form of machine learning and various technologies that one could argue fall under the AI umbrella. Then it's a question, again, whenever somebody asks, are you using AI for something? The first question in my mind is always, what is AI to you? Are we talking about highly advanced AI? Are we talking about the sort of techniques we have been using for years and years already, like machine learning? But definitely, I see more of that in future. So we are, as said, already using a lot of technologies to detect attacks. We are using a lot of technologies to prevent them. Even the good old ones like antivirus are largely already based on this, and more advanced stuff is coming out all the time. We are definitely doing work also in the back end to work on this. One thing I just want to point out is that the OEMs are in a slightly bad position on this one, because we almost never provide everything for the vessel. So it's usually the vessel out there. It's not a floating engine that is floating on there on its own. It's a vessel with an engine and thrusters and all these things. So you have to look at it from the perspective of the vessel and all the services and operations. And there we are in a bit of a bad spot, because, again, we are not providing all of that. So it might be half us, half somebody else. And now you have to look at the bigger picture. And this is usually where the yard or the owner comes in and says, hey, I will implement these techniques based on knowing what is in the vessel. So we can definitely help you there, but we can rarely be the solution to that entire problem.
Yeah, but I think class also has a good role to play, because they also have the overview of the entire ship, and to be able to class it cyber safe, they would also have certain things to follow, and taking everything in totality.
It's just mainly, and this is a pet peeve of mine, because we get a lot of questions from customers and different people asking us whether we can solve all the cyber problems. And I always keep telling them that, if I'm selling you an engine, there is certain things I can solve and certain things I cannot. So all the parties you mentioned are definitely in some ways in a better position, because cyber needs to be thought about from the vessel perspective, not only from the engine and so on. So
yeah, I think from a customer's perspective, it's always easier to knock on just one person's door than to go and knock on 10 people's door. But well, that's life.
that is life.
I don't have any other questions. Oh, okay. One question for Nori. Are you aware of any other countries other than Japan that intend to introduce guidelines for or perform social implementation of MES ahead of IMO? You are muted. Nori-san, you are muted.
Sorry.
Yes.
And some of the European countries has been already their social implementation for some kind of demand. Also, IMO regulation is not required for the domestic implementation for every country. But it's better for us to provide some kind of guideline from IMO to adapt to domestic. But to tell the truth, the social implementation within the country is a very earlier compared with the schedule of the IMO. That we have to think about develop our guideline by self for every class society thinking about that right now.
All right, thank you. I think this is also a bit related to what Päivi mentioned earlier, that if you have a certain fixed route and the sea conditions are relatively stable, then perhaps within a country they are able to implement some sort of guidelines for very specifically for that route, for that class of vessels. For example, either coastal vessels or even inland water vessels, just as sort of a way to do a proof of concept, whether this thing is implementable within a country before probably being able to, suggest it at IMO. Yeah.
Yeah.
Okay, I have one question that I think everybody would be interested in. Will the presenter's slides be provided? So I can answer the first part, which is that we have recorded this webinar, and with the panelists' blessings, we will then share this recording in a few days' time. So we will also be reaching out to the different panelists to get them to share the slides, and these will also be uploaded on the iTrust website. We will then also publish this in our LinkedIn, so you can also get the link from there. Yeah. Any other questions? I think we have time for just one more before we do the closing. I think David Ong from Attila Cybertech, he's in the audience. He raised his hand, but I'm not sure if he's still around. So David, if you're still around, feel free to. Okay. If there are no further questions, can I now invite Prof to closing remarks?
Okay, thanks again to our speakers, Nori, Pavi, Victor, and Matis for today's presentation in our webinar. I hope the webinar will trigger more attention on the new cybersecurity challenges in autonomous ships. In the maritime industry, we have seen an urgent need to develop and deploy cybersecurity technologies in order to cope with surging attacks. On the other hand, we lack a safe and realistic environment to test and validate new cybersecurity technologies before being adopted. So we try to fill this gap by building a new maritime testbed in iTrust. We would like to thank the support from Singapore Maritime Institute and the Maritime Authority of Singapore for this project. The new model testbed will include the major shipboard OT systems, and the majority of them will be hardware components. It will provide an open framework to connect and configure different components. Our model testbed can be used for research and development, for professional training, and also for cyber drill and technology validation. So if you are interested in our testbed, please let us know. We will be happy to explore the opportunity for collaboration. We will continue to organize webinars in the series of maritime cybersecurity, especially about the new guidelines for cyber risk management of autonomous ships, and also the new testbed for maritime cybersecurity. So stay tuned. Thank you very much.
Thank you.
All right, thank you, Jin. Thank you. We've come to the end of the webinar. Thanks everyone for joining and staying back for the Q&A. And also thank you so much for the panelists for sharing their thoughts, their feedback, their insights. And as I mentioned, we'll be sending out an email after the webinar to let you know where we can download the video recording and the slides for the webinar. And as I mentioned earlier at the start of the webinar, we will be still organizing a few more. So, do keep a lookout for invitations. So have a good long weekend ahead, and we'll see you very soon. Thank you so much.
Thank you, everybody. Bye.
Thank you very
Thanks.
much.
Bye-bye.
Bye.